Okay, let's keep going then. So next we're going to use, so now we're going to solve this using that TVM solver. All right. So here we have FV is 0, right? Again, you want that to be 0 with the loan because you want to be able to pay off the loan. Okay, that's what you want to do, pay off the loan. Right, our PMT, which is our monthly payment, this is negative 250. The payments, right, it's a cash outflow from us, from her, excuse me, from Marie. So it's going to be negative. Okay. I, we have is 7%, right? Again, you don't convert, you leave that as a percent. Capital N is little n times t, which is 12 times 5, which is 60. Okay, again, it's being compounded 12 times per year times 5 years. So we have 12 times 5. That's how many times it's compounded throughout the context of the problem. PV is what we're looking for, right? The initial loan balance. These two, P/Y, C/Y, right? Those are monthly payments. Excuse me, those are 12. What am I saying? They're both equal to 12, right? P/Y, that's how many payments you make a year. C/Y is how often the account is compounded. But again, they're both equal to 12 here. All right, and so again, let's put that in the solver, the wonderful TVM solver that we all like. Okay. All right, here we go. So we have capital N, 60. Wait, no, here we go. 60. 60, there we go, finally. So we got a capital I is 7, right? PV is, that's what we're looking for. So really this, I guess we can just leave that, blank. PMT is negative 250, right? FB, it's 0, we want to pay off the loan. These two are 12. Good. Good. All right, good. Okay, so now we enter in the data. Excuse me, we put the data in, we did that. What's PV? We're solving for that. We get the same thing. $12,625 and let me see, we can 50 cents. Good. Okay. You know, make sure you click in here because sometimes, depending on the number, you may not see the whole number at first, the entire number, that is, the decimal part. I mean, here we do, but not always. You know, what if it came out to be like this? Right? See, initially you can't see the entire number, so make sure you scroll around a bit. Right? Good. All right. Hope that made sense. Let me stop this. Let me get back to the notes. Here we go. Beautiful. Oh, darn it. Press the spell checker by mistake. All right. All right, good. So either way we get the loan balance, we get that to be $12,625.50. Okay. Now, so why did I have 50? That's a 1 there. What do I have? That? Okay. That must be a typo. Anyway, let me fix that. So it should be 50 cents, not 51 cents. So sorry about that. Just fix that. Okay, anyway. There we go. 237456. All right. I just had to double check the calculation. All right. Anyway, so this is what our P0 is, okay? It's equal to this. So that's the most expensive car she's able to get. Now remember, for number 2, we want to know how much money she is sending the loan company. You know, how much she's paying overall. She's paying $250 a month for 5 years, right? Okay, so because of that, we have $250 per month, right? Times 12 months per year, okay? And then we have times 5 years, right? So the units cancel, which is what should happen. So altogether, we're going to get $250 times 12 times 5, which is $15,000. $15,000, okay? And how much of that is interest? This is what I just had to fix. You know, this is the loan amount, right? But anything that she pays beyond the loan amount is interest. Anything over this amount covers the interest. So in other words, for the interest, this is what we do. Take how much we're paying, subtract the loan balance that we're paying off, and the rest is interest. You know, that's what we get. So she's paying this much in interest. So that's what we get here. Good. Okay. Any questions on this? Okay. So here's another one. I was going to have everyone try this, but let's just do it. Let's suppose now it turns out that Marie made a mistake. And let's say it turns out, though, that she's actually able to make $300. She's able to pay $300 per month for a car payment. So she can afford a $300 per month car payment, it turns out. And now the interest is going to be 9% interest. Excuse me. And this loan will be at 9% interest for 6 years. Through a different loan company, she's able to get that. So we want to know, how expensive of a car is she able to afford? You know, just like before, we're basically asking how big is the loan amount. Assuming all this, she's able to make $300 per month car payment. The interest rate is 9% and 6 years. We want to know how much total money she's going to pay the loan company, the new one. You know, it's just like what we did over here. You know, how much is she paying in total? And then to get the interest, you know, it's just like what we did over here, right? How much she's paying, subtract the loan amount. You know, anything you're paying off beyond the loan amount is the interest. You know, that's how you get the interest. Okay, so let's use the formula. P0 again, it's really just like before, right? P0 is our unknown. Okay? PMT is 300, right? You know, that's what we're assuming. R is 0.09. You know, if you're using the formula, your R, your interest rate, excuse me, it's your interest rate, but you convert it to a decimal. N is 12. T is 6. Okay, so that's what we get here. This is what we get. Okay, so using our formula, we put everything in. 300, 1 minus 1 plus 0.09 over 12, raised to the negative 12 times 6 over 0.09 over 12. Okay, this is what we have, right? We're just plugging everything in. P0 is what we're looking for, so we have to do this big calculation. That's what we have to do. Okay. All right, so it's just like before, right? What we have to do is order of operations, essentially. In other words, we have to do order of operations. So what's in parentheses, in the innermost parentheses, we do first. We do 1 plus 0.09 over 12, right? Here. So that's 1 plus 0.0075, okay? And then we do 1 plus that, as you can see, that's 1.0075. We're raising that to the negative 72, negative 12 times 6, which is negative 72. And then we're dividing by, okay, and then we have all this. Okay, so what is this raised to the negative 72? This is what we get. 1 minus this turns out to be this number. And of course, also 0.09 over 12 in the denominator we did. This whole calculation turns out to be this. So this is what we get. All right, that's good. That's good. Okay, now that's by the formula. Okay, let's try the TVM solver. Are there any questions on this stuff? All right. Oh, wait. Okay, here we go. So let me get to the TVM solver. Let me stop sharing this. Good. Let me clear this. So again, we have to put in our data, right? Oh wait, I think I went too far ahead. Sorry, I shared this before. I shared this before. I shared it too early because we want to do this first. Sorry about that. Here we go. So again, it's the same problem, but we want to use the TVM solver. Okay, so what's going to change? Well, FV is going to be the same because again, you always want to be able to pay off the loan. You know, FV is the loan, is how much the balance is after, in this case, 6 years. But you want that to be 0. You don't want to owe anything. PMT is negative 300, right? We're paying $300 a month, monthly payments. Excuse me. I is 9%, right? The interest, but you leave it as a percent. Capital N is how many times the account is compounded a year. 6 years, right? But it's compounded monthly since we're making monthly payments 12 times per year. So 12 times 6, 72. PV is what we're looking for. That's the loan balance initially. And these two we know are equal to 12. I mean, P/Y is how many payments we make per year. C/Y is how many times the account is compounded per year, which is 12 as well. Okay, so now let's go to the TVM solver. Okay. Wait, let me share it.